Hello, my name is Arghya Bandyopadhyay, and I'll be presenting my work, Unsupervised Objective Criterion Choice for Optimal Single Molecule Analysis, which I completed with the help of Dr. Marcel Goljan-Ohm in the Department of Neuroscience. In this work, we analyze DISC, or the Divisive Segmentation and Clustering algorithm, which is used for idealizing single molecule data. Idealization is a process where we take noisy data and try and find the true underlying data which generated it. However, as we see in this figure, two different objective criterion which guide DISC's idealization, BIC RSS and BIC GMM, lead to different performance on this trace. We found that this differing performance was dependent on the data conditions of the underlying trace, as low signal to noise, low length data, as seen in this corner over here, were optimal for BIC RSS. However, high signal to noise, high length data, as seen in this corner over here, BIC GMM was optimal. We use this condition space data to figure out an optimal decision boundary to separate regimes where GMM was preferred and where RSS was preferred. Finally, we developed a somewhat sophisticated workflow to determine the underlying signal to noise ratio of a given trace, which is notoriously hard to estimate if you don't already know the signal, the underlying signal. So here we use DISC to create an initial fit and then perform k-means clustering on the step heights of this fit to determine the signal, and then perform a Gaussian fit on the residuals between this fit and the raw data to determine the noise level. Finally, we use this signal and this noise to estimate the signal to noise ratio and already know the number of points in the input time series. And so we can plot a point on this condition space map and figure out which side of the boundary the point falls to determine which OC would be optimal for the given input time series. This is a huge practical solution to allow for high throughput analysis of single molecule time series. Thank you.